All right, our third day of algebra review is going to be about quadratic equations and how do we solve those using square roots and factoring and all of that good stuff. So this is something that you'll definitely see a little bit at the beginning of the year and then again a lot at the end of the year. So we really need to remember how to solve these quadratic equations. So just to start off with, factoring is one of our methods for solving quadratic equations. So as a warm-up, I have listed out the different methods for factoring, and I'm just wondering if you remember how many terms your polynomial needs to have in order to use that method of factoring, and maybe just kind of remember what that looks like a little bit. So see what you can do if you pause your video and put those number of terms, I've given you the choices over there in the yellow boxes, put them in the right spots to match up with that method of factoring. So the top method was greatest common factor, or GCF. So this is when you have something that would look like 5x squared plus 15x, right? And you say, oh, those have a common factor of 5x. And so then I say, okay, well, what's left? This would be, I would have just an x left from this one, and 5x times 3 would give me 15x, so this would be factoring by GCF. Now, the one that I used right here was 2 terms. However, if you had 3 terms or 4 terms or 5 terms or however many terms you want, if they all have something in common, you can use GCF. So this top one is any number of terms. That's what goes with GCF, okay? Now the next one was binomial guess and check, or factor box, or X method, or whatever method you use. We never did come up with a really great name for that one. So that one would be if you had something like x squared plus 2x minus, I had one in mind and now I forgot it, minus, let's see. Well, here, let's do this. Okay. How about x squared minus 6x plus 5? And that would be x minus 5 times x minus 1 would give you x squared minus 6x plus 5. So if you kind of look at that, that has to have 3 terms. If you think of your factor box, the factor boxes looked like this, right? And you had your spots right up here and right down in the nook. So that one had to be 3 terms. Whoops. I'm just making some room here. So the factor box, or our binomial guess and check, this had to be 3 terms to do this. Binomial squared, the bin squared shortcut, this one would also be 3 terms. It looks very similar to a factor box. However, the 2 terms would be like x plus 3 times x plus 3, right? It's when both of those are the same thing, or x plus 3 squared. So it looks very similar to a factor box, so it also is 3 terms for that one. The difference of 2 squares, this one, dots, difference of 2 squares has to be 2 terms. So dots was one that looked like this, x squared minus 49, right? Both of those 2 terms have to be perfect squares. This was x plus 7 times x minus 7. That was what dots was all about. So that was 2 terms. And our last method was grouping, and grouping obviously would have to be 4 terms. So grouping is one that we don't use a ton, but it is definitely one that you learned last year. So you have to have 4 terms in order to use grouping. All right, but the most common ones that we're going to use this year are GCF for sure. And then this binomial guess and check, or the factor box. And then bin squared will pop up. You can remember that one, that's awesome. But you can always use the factor box there as well. Okay, so this is just our methods of factoring. Now, let's talk about what are our ways of solving a quadratic equation. So I kind of gave you a hint in the beginning there of what we were going to do today, and then in the last slide when we were talking about how to factor, that's definitely one of them. But the first and easiest, the first and easiest method for solving a quadratic equation is to use square roots. Okay, so to use square roots, right, that's this symbol, right, you have to have an x squared but no x term. Okay, so anytime you have an x squared but no x term, you can use square roots to solve it. And we'll practice that in a minute. But that's the really important thing to remember, is that you have to have an x squared but no x term. The next method that we just spent a whole bunch of time talking about was factoring, right? Factoring you could use if you have x squared and x terms. All right, so if you have both x squared and an x term, then we can use factoring, right? And so big things that we're talking about for factoring are factor box and GCF. And those are the main ways of factoring that we're going to be using. Now, I know that you're thinking, but Ms. Grebo, there's one more way. Isn't there like that thing called the quadratic formula? Yeah, there is the quadratic formula, and we spent a lot of time working on that last year. But the thing with the quadratic formula, man, I'm all over the place today, sorry, is this is only if nothing else works. You guys this year want to just jump straight to that. You just want to jump straight to the quadratic formula, and there's so many easier ways that will save you time, and trust me, this year you are going to want to save time. So we'll write down that yes, that is an option, that is a way to do it, but I promise you, use factoring, use square roots. They're faster, they're easier, you'll make less mistakes. So we're not even going to really practice quadratic formula today, because that's just a last extreme resort, and I guarantee you can do these problems using square roots or factoring, okay? All right, so those are our methods. All right, so here's our first problem. 10k squared plus 9 equals 1009. Now, if you notice, I have a k squared term, and that's it. There's no k term, which means we can use square roots. Okay, this is what I mean by an x squared but no x, right? If all you have is something squared, then you definitely want to use square roots. Don't use a factor box or quadratic formula by any means, please, okay? So if I'm going to use square roots, I need to get k squared alone first. Once k squared is completely by itself, then you can use the square root, okay? So my first step is going to be to move the 9. So I'm going to subtract 9 from both sides. I get 10k squared equals 1000. All right. Now, I cannot take a square root yet because I have to get k squared alone, and I don't have k squared alone yet. So next thing I have to do is divide by 10. So I have k squared equals 100. Now, k squared is alone. So now, to undo squared, I take a square root. All right, remember, square root really means what number times itself equals 100, right? What number times itself equals 100? Well, 10, right? 10 times 10 equals 100, but also negative 10, right? When we have a quadratic equation like this, we should almost always have two answers. Be ready for that, right? Okay, especially when you use a square root. When you take a square root, you should have a positive and a negative in the next step, right? Two answers, because 10 times 10 gives you 100, but negative 10 times negative 10 equals 100 as well. So always plus or minus there, right? We did have the symbol, if you remember, and you can use it if you want to. You could say k equals plus or minus 10. That would be a perfectly acceptable answer as well. Either way you want to write it is fine, but you should always have that plus or minus option on the next step after you do a square root. All right, there is our basic. Let's see what we got here. Negative 12 plus 9x squared equals negative 8. You can always pause your videos here, see if you can do this one on your own. I see an x squared here, no x. So again, we're going to use our square roots, right? X squared and no x equals square roots. So again, we want to get x squared alone before we take a square root. So here we go. Let's see. First step then, I'm going to move the 12. Okay. So I have 9x squared equals negative 8 plus 12 is 4. Now I'm going to divide both sides by 9. I cannot take the square root. Can't square root until x squared is alone. All right, be careful. Do not take the square root until that x squared is all alone. Now you're probably telling me, but Ms. Crevo, oh no, I can't do 4 divided by 9. Should I do a decimal? The answer is no. Don't ever do a decimal when you know you're going to do a square root. It's a fraction. Just leave it as the fraction. I promise you it's going to work out, okay? So we're just going to have 4 over 9, and that's how it's going to stay. Now the x squared is alone, so now I can take my square roots of both sides, right? X squared and square root and squared cancel each other out, so I get x on this side. Now, what times itself gives me 4 over 9? Well, you can always think of this, right? This is the same thing as the square root of 4 over the square root of 9. That's the same. So what times itself gives me 4? Okay, 2. What times itself gives me 9? 3. So it could be 2 over 3, or it could be negative 2 over 3, right? We always have those two answers, even if there's fractions. Don't forget your plus or minus. All right, so even if it's a fraction, it's okay. Just take the square root of the top and the square root of the bottom. And remember, you'll have one positive and one negative. Okay. Let's see, maybe you could do this one on your own. We've got 5n squared minus 1 equals 99. So again, I have an n squared and no n, so this will be square roots. First step is to get that n squared by itself, so I'm going to add 1 to both sides. So I have 5n squared equals 100. Do not take that square root yet. You have to get n squared by itself. I'm going to divide by 5. I get n squared equals 20. Is 20 a perfect square? If I take the square root and say what times itself equals 20? It's not a perfect square, but that's okay. Don't give me a decimal, okay? No decimals. Simplify the radical. You spent an entire unit on this last year. You can do it. I'm sure once I start saying it, it's going to come back to you, right? So this is where we say, okay, what are the factors of 20, where one of them is a perfect square? Hey, you just did this the other day, right? So you should be able to simplify that radical really quickly. Okay, this is square root of 4 times the square root of 5, right? Okay. Square root of 4 is my perfect square, so this is going to become 2. Square root of 5 can't do anything with, so I'm going to use 2 radical 5. So I have n equals 2 radical 5, but don't forget, you should always have two answers. So I have 2 radical 5 or negative 2 radical 5, and I still have my two answers, right? So even if it's not a perfect square, you're still going to have those two answers, positive or negative. Now again, you could write that using the plus or minus. That would be n equals plus or minus 2 radical 5. That's perfectly fine way to write that as well. All right, I feel like you guys should be pretty solid on using those square roots now, right? We talked about just a regular one with that perfect square. We talked about a fraction that's going to happen this year, and we talked about our non-perfect squares. Just simplify those radicals. Don't ever give a decimal, okay?